So, hello everyone. This is lecture 9 of Artificial and Robotic Vision System. So today we're gonna talk about how we can combine convolutional neural networks and all the tricks that we learn into a global vision system that can start to approximate slowly vision system of mammals and maybe of our own as well. So first of all, I wanted to describe what I think is the visual intelligence, or what I consider the definition of a visual intelligence, which is basically telling you what a visual system is supposed to be able to do. This is just my definition of visual intelligence, and I actually welcome comments about this. But it seemed to me that is a pretty good overview of what needs to be done. So visual intelligence is basically the ability of being able to track targets, so some objects or something of interest, while they are on the scene, keep this target in memory if they disappear, and then recognize them again when they reappear. And this memory could be short time or a longer time, short-lived or longer-lived. So what I mean by targets are objects or part of the scene that we want to identify, that are important to us at a certain moment. The scene is the full environment perceived by visual system. So it's the whole image, the whole panoramic view the visual system can accept as input. And memory is basically a list of targets and their identifying features so that you can distinguish one from another. So why do I think that this is visual intelligence? Because keeping a list of target in memory can be used to infer higher order statistic in behavior of the target in the scene. So this is really the foundation of intelligence, behavior, and interaction with the environment. For example, I could recognize as target a paper and a pencil, and I could see that they're often on a table. And so I could identify as second order statistic the fact that this, if I see a pen, or if I look at something elongated on a table, it's very likely to be a pen, even if I don't perceive all of its features or I didn't manipulate it. And in fact, sometimes you might go and pick up a pen and it's not really a pen, it's just a metal rod. So I hope this gives you an idea of what I mean by visual intelligence and what these visual systems are supposed to do. Now, let's look at what has happened in the last 50 or 60 years. Computer vision has been around for a while as a science that is supposed to basically computerize vision, create software algorithms that can create a visual system like our own and give you the ability of seeing. This document here, the Project MAC, Massachusetts Institute of Technology or Computer Vision, July 7, 1966, circulated a lot in the internet, especially recently. It was supposed to be a summer vision project by a few professors there that were gonna hire a few undergraduate students and break down the project, summer workers to construct significant part of a visual system. And we will just segment the problem of vision into sub-problems, and we'll allow individuals to work independently and then yet be able to construct a visual system that can do pattern recognition. So this was 1966, and now we are 60 years later practically, and we still don't have a visual system like the one that we wanted in 1966. What could be the causes? Well, the causes could be many, but I think the major causes really, one of them is that not really taking into account the biology and taking into inspiration biological system, how they would do this. Partly because at the time maybe there was limited knowledge about the system. This is debatable, as even today our knowledge has not increased much on how the visual system really actually works, besides small details. But really one of the really big problems of looking at computer vision with a bio-inspired eye, as I say, is what did we learn? Really the big problem, I think, was studying these pieces in isolation. So they thought that vision could be decomposed in parts, segmentation, stereo, optical flow, recognition, tracking. They're all separate parts. We can just work on it independently and then have each just put together all these parts and be done with it. Obviously, this hasn't worked, and I think this is really the major problem, and a problem that I'm trying to give insight here on how can be solved and overcome. If we don't overcome this problem of putting together pieces in isolation, the field of vision system will not improve, whether it's bio-inspired or it's math-inspired or computer vision inspired. So, in my opinion, you cannot look at pieces of vision in isolation. We form a synergy together. The system is really entangled. If you look at visual system in humans, it's really entangled. Multiple parts that collaborate together. The parts help the whole system, and it's also extremely inefficient to do the same operation in multiple algorithms, multiple systems. What do I mean? And what's the solution really? The solution to this problem is a unified model. It's a unified model that can replicate human vision in one system, basically, and is able to tackle general problems. The problems identified by the visual intelligence definition that I reported before. The idea is to train only one system, not a bag of tricks or multiple systems. And the idea is also to reuse the same processing element for multiple modules so that you don't have inefficiency. For example, you might use Gabor filter, orientation filter for multiple algorithms like categorizing, segmenting, tracking. You might use contrast normalization on the input to many modules. And the first or second layer filters of a COMNet. A layer of a COMNet might be the identical process that is done in all of these module pieces in isolation that we've seen.